Welcome once again to my YouTube channel. Today we are taking a topic on heat capacity and a specific heat capacity. Now, what's this very heat capacity? Now, let's take for example, you have a liquid in a container. We have it filled. Now, this very liquid, for example, water. Now, this very water, I want to raise the temperature of it. Maybe its initial temperature is 25 degrees Celsius. Now, I want to raise this temperature from 25 degrees Celsius to 26 degrees Celsius, which means I want to increase the temperature through 1 degree Celsius. So, difference between 25 and the 26 is what? That should be 1 degree rise in temperature, right? So, I want to raise this water through 1 degree rise in temperature. Now, for me to do that, I need heat. Now, there is a specific quantity of heat that is capable of doing so. Now, if I apply such a heat that will do the job, such a heat will raise the temperature of this very water through 1 degree rise in temperature. That quantity of heat is what we call heat capacity. So, in that case, we say that heat capacity is the quantity of heat, the quantity of heat required to raise the temperature of a system through 1 degree rise in Kelvin temperature. Now, this quantity of heat required can be expressed mathematically. Now we have heat capacity, which has this very formula, the symbol. Now is the quantity of heat required to raise the temperature. This is the temperature rise now. So to raise this very temperature through 1 degree rise, okay? Now, the heat capacity has a unit, such as other quantities. Heat is measured in joule, temperature is measured in Kelvin or Celsius. So in that case, we have the unit of heat capacity as joule per Kelvin or joule per Celsius. Now, if you make H the subject, you are having the quantity of heat as the heat capacity times temperature rise. So in that case, you have this as a formula of heat. Now, let's take specific heat capacity. So, specific heat capacity now coming to specific heat capacity, let's also take the case of that liquid where you have a liquid such as water, but in this case, the quantity of water in that case has to be specific, okay? It has to be specific. Maybe this water now is 1 kilogram, 1 kilogram of water, okay? Just a unit quantity here. We have 1 kilogram water. Now, this 1 kilogram water, we need to increase the temperature of it. Maybe again from 25 degrees Celsius to 26 degrees Celsius. That is through 1 degree rise in temperature. Okay? So to raise this very temperature, the unit mass through 1 degree rise in temperature, there is a quantity of heat required as well. Okay? Remember, the mass of water is specific. 1 unit of it, 1 kilogram of it. So to raise that very temperature, we require what? A quantity of heat that is capable of doing so. Now, this quantity of heat that is required in order to raise this 1 kilogram of water to 1 degree rise in temperature, that is what we call heat capacity, specific heat capacity, okay? So in that case, we said specific heat capacity is the quantity of heat, the quantity of heat required to raise the temperature of 1 unit, the temperature of 1 unit, or the temperature of a unit mass, that is 1 kilogram, through 1 degree rise in Kelvin temperature. So that's what the specific heat capacity. Remember, the mass is specific, unlike the heat capacity. Now, mathematically, we have the specific heat capacity as the quantity of heat required to raise a unit mass of that very substance through 1 degree rise in temperature. So the unit of this specific heat capacity will now be derived from this very quantity. Heat is measured in joule, mass is measured in kilogram, so per kilogram. Temperature is measured in Kelvin per Kelvin. So in that case, the unit of specific heat capacity becomes joule per kilogram per Kelvin, or joule per kilogram per Celsius. So this could be the units. Any of them could go. So at this very point, you will now agree with me that the difference between specific heat capacity and the heat capacity is that the specific heat capacity, the mass has to be specific, 1 kilogram. But coming to heat capacity, the mass is not specific. Both heat capacity and the specific heat capacity, we tend to raise the temperature of that very substance through 1 degree Celsius. But only difference is that the mass of that specific heat capacity has to be specific. Okay? Now, from what we have as the formula, if you make H the subject there, we are going to have H equal to C here with times m theta, we have mc theta, we have equation 2. Remember, initially we got equation 1 from heat capacity, which is C theta, which is equation 1. If you compare both of them now, you are going to have what? mc theta, this very one, equal to, this one is heat capacity, right? So mc theta, which is specific heat capacity, equal to heat capacity. So we have this. So the temperature here we cancel out. So we have the mc equal to specific heat capacity. And this gives the relationship between specific heat capacity and the heat capacity. So if what we did was able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.